This lesson here is 10.2, finding arc measures. In specific, we're going to find arc measures that are central arcs. We'll find that there are arcs that can be inscribed and other different type, inside, outside, um, angles as well. So just be aware that this is the basic version. So, measuring arcs. The measure of a minor arc is the measure of its central angle, meaning this angle ACB is equal to the arc AB. Now, what is arc? Right? Arc is basically a portion or percentage of the entire circle. Right? So an entire circle is 360 degrees. A minor arc would be between 0 and 180, kind of like an acute angle, but the difference is it goes all the way to 180. And key is that a minor arc only uses two letters, because you could say, well, I got here, arc AB is clearly got to be 50, but someone else might say, well, what if we went this way and I got 310? Well, to clarify the difference, a minor arc is going to use two letters, and that's again always two letters is less than 180. If it's 180 exactly, it'll be three letters. If it is more than 180 and less than 360, right, typically we're going to be three letters, right? We should be. So ADB tells you we're going A to B. We have to go through point D on the way. So that means this value. And to solve, if we knew AB is 50, we could do 360 whole circle minus 50 is 310, which it gives us that kind of Pac-Man looking shape. Now, if you do have a semicircle, right, that the line that goes through the dot that identifies itself as a center all the way through would tell you it's a semicircle. Well, the eighth would tell you the line is a diameter. If we have a diameter, that is also going to be 180 degrees of a circle for arc measure. So, starting off, find the indicated arc measures. Now, whom would you rather meet? Musician, athlete, inventor, actor, other, right? If you can meet anybody. And so based on this um, poll, they gave us the degrees of each slice, right? Now, finding the measure of arc AC, right? AC is from here to here, so inventors to magicians, right? We would do 29 plus 108, and we would get 137. If we want to do ADC, right, notice we would go the other way, right? Now, since we already did AC, ADC was going to be 360 minus this answer. So a short way would be 360 minus 137. Now, we could also do 79 plus 61 to give us 140 plus 83 would also equal 223. Now, typically I will show the easiest way to do it, even if there's more than one. ACD would be here all the way to here. So we could do these three added together or 360 minus these two. Both of them are going to be a little bit of work, so I just added all three. And so 108 plus 83 plus 29, largest to smallest. So we got 191 plus 29, 130, 200, 220 total. And EBD is EBD, everything but 61, so 360 minus 61 is 299. So notice that we use 360 in the circle a lot if it means, hey, 360 minus these two numbers versus adding 3. Sometimes it'll be shorter. For sure you want to be able to use your calculator unless you love subtracting and adding two-digit numbers or three-digit. Identify the given arc as major, minor, or semicircle and find its measure. So go ahead, try this basic example on your own if you're feeling confident. Remember, straight lines add to 180. Now, hopefully you paused for that one. Right, we've got 120, 60, and 80. We can find the missing part, and of course, that's our first piece. So we could do either 180 minus 80, or we could do 360 minus the rest. So you do have a couple options there because these add to 180, these need to add to 180. We could have just done that and found 100. This is another way you could have done it if you just weren't confident about it being a straight line. Maybe the lines don't look quite as straight as you think they should. Right, 180, 360 minus 120, 240 minus 80, 160 minus 60, 60, right? And 100 is less than 180, so that would be a minor arc. And just by having two letters, we could say it's a minor. So one of these is going to be a semicircle or both major arcs, right? So TSR, TR goes straight through this point, and so that should be semicircle. And I think I did the math, right? You could have noticed right away it's 180 or 100 because we just found this side plus 80 to get us 180. Lastly, SQT is everything but 80, so 360 minus 80 would give us 280. Now, I had a label somewhere here, and that is a semicircle. Now, that bottom one is a major arc, right? So 3 letters for semicircle form, major arc. Two circles are congruent when they have the same radius. Sounds pretty straightforward. That's only the only label a circle can have. Two arcs are congruent, so now how can we tell if we have congruent arcs? Same degree measure that we were just talking about, and they're either in the same circle or congruent circles. So if they aren't the same circle, make sure you have some sort of radius congruent or some information tells maybe they're not congruent, so you know that the arcs aren't going to be congruent. If two circles are congruent, we write circle P congruent to circle R, right? And just do the circle symbol, usually with a dot right in the middle. My center was not so great. Are the arcs congruent? So kind of look at them, make a quick formulation in your mind. Is it going to be congruent circles? Yes, no. Are the numbers equal? And go. 80 equals 80. We're in one circle. I would say yes. And we've got yes, same circle. 80 is 80. So arc CD, measure of arc CD equals measure of arc EF. That is a symbol for that, by the way. I don't know if I went over that. Sometimes they use nice and lofty, and some of these are less curved. So sorry to randomly go back to that. But next, the bottom one, we have, they try to make it look like it's the same circle, but clearly one circle is much smaller than the other. This is clearly going to be no. Next one, we've got 145, 145. Do we have our radius congruent? Sorry. 145 match. I see this mark means the radius are congruent, and or radii, pardon me, and therefore radius are equal. 145 is 145, so AB arc is congruent to CD arc. And that is 10-2. So pretty straightforward. Central angles are congruent to central arcs. So if we have angles in the center congruent, we can say the arcs are congruent and vice versa, because we will use that in proving theorems in lesson 10.